today we will see how you will observe, practically you will observe, how blood is taken into the tube. If it goes, there is one mark, 101 mark. You have to take blood up to 0.5. Okay. So first thing here, I'm starting with this. So I can see there are so many marks. And 0.5 mark is also there. And below it there is one mark, and over 0.5 there is one mark. So you will draw blood up to lower mark. Why lower mark? Why not upper one? Why not upper one?
So because the blood will go to the where that bead is there, we can mix it there.
Actually, this is 0.1, 0.2, 0.3, 0.4, 0.5. So that 0.5 mark is just below the digit 0.5. So you will be drawing blood up to 0.5. So while you will be drawing blood either from your fingertip or from the cuvette, so from there you will be drawing, and it may not be exactly 0.5. It will be always, you should take more than 0.5. If you can take 0.5, okay. But why I am telling you take more than this. And thereafter, after taking this, then what you have to, there will be blood around the tip here. So you have to wipe this extra blood. Okay. So there is no blood surrounding the tube or at the outer surface of the tube. Now the blood level is over 0.5. Now you have to bring it down to normal, that mark. How will we be doing? By touching with cotton or blotting paper, filter paper. Okay. And if you touch the cotton like this, it will come down below the mark. So you just touch it. Repeat. Then it will be coming to required. Then in a container there will be RBC diluting fluid. What is there in RBC diluting fluid?
Sodium sulfate, sodium chloride,
Silver chloride.
T3, sodium chloride.
Okay. What is the function of sodium sulfate?
Priming of RBCs, degradation of RBCs.
It prevents piling of RBC. That is, there is a term for this. Roliform. So, to avoid this, we are using sodium sulfate. Why do we use sodium chloride? Is it necessary?
Yes.
Okay. Why it is necessary? Why it is necessary? Show me. Why it is necessary to maintain the surrounding isotonic?
Maintain the morphology.
Maintain the morphology. If it is hypertonic, RBC will shrink. If the surrounding is hypotonic, RBC will collect fluid and it will burst. So there will be hemolysis. The morphology, so you have to identify the morphology, you have to count, but it has lost its morphology. How can you identify that? So surrounding should be isotonic so that its morphology is kept intact. So that's why we are using
Sodium chloride.
sodium chloride, and point.
Mercury chloride.
What is the quantity?
0.2.5 to 4.5.
0.25.
4.5.
0.5. 0.25.
It is mercury, na?
Mercury.
Sir, 4.5.
4.5. 4.5. 5 gram. If you add 5 gram in 100 ml, the quantity of distilled water is 100 ml. So then what is the strength now? 0.5 or 5%. So we know for human being, the saline, what is saline? When a patient is suffering from hypovolemia, there is loss of water loss because of diarrhea, dysentery, vomiting. So for several reasons, or blood loss, so they will be needing saline. So what is this saline?
Electrolytes and water. Electrolytes and water.
Electrolytes and so what you can do? Buy some electrolyte, sodium chloride, and add in water. Okay, then infuse it. It will be sodium chloride solution is saline. No, not at all. Not at all. This solution should be isotonic to my cell, to my body water, to my ECF, to my blood. We are having body fluids, no? That is having a particular osmotic pressure. So the fluid I am injecting, that should also be isotonic. So in that fluid, whatever you add, its osmotic pressure should be isotonic to the body fluid. So if you want to give only the salt solution, so there also its strength should be 0.5 gram percent. 0.5. Okay. 100 ml will contain 5 gram. This is saline. So sometimes we make saline adding dextrose saline. Means adding glucose. This will prove the patient is unable to eat anything. So he needs nutrition. So that will be provided. No, he can't drink also. So through saline. In that case, the patient will be having glucose. Dextrose means glucose through saline. So that also should be having the same isotonic strength. Okay. So that is the necessity of isotonicity. Okay. So now what we will be doing? You have taken the blood. So if you take long time, the blood will be clotted. So before clotting, you have to dilute it. Before clotting. So my RBC diluting fluid is ready. Oh, you didn't say what is the function of mercury chloride?
Preservative.
It will prevent growth of bacteria, viruses. Because after making it, I may be, patient has come, I have taken this, done this, I may be examining it in the afternoon, in the evening. So during this process, there may be contamination of microorganisms. So they may spoil the RBCs. Okay. So when we started with a blood. We collected the blood from the refrigerator, it is preserved there. And when we diluted it and charged and under the the hemocytometer, then what we see, not a single RBC is there, only fine dots are coming. That means RBCs are hemolyzed. So then fresh blood was taken, then only we could do it. So hopefully with that blood today also we are going to do. So hopefully this is okay today. No, sure. So now what we'll be doing, in a container there will be diluting fluid. Then you will be drawing RBC diluting fluid into this. Okay. So we are supposed to take up to this. So while sucking, you follow the level, upper meniscus of the fluid. So it is coming. Now it has reached to the bulb. Again, continue it. It has exceeded this level. Immediately, you take out and make it horizontal. Okay. Then you do one thing, fold it. Now make it vertical. Fluid will not be coming out. Okay. Now see the level. Okay, blood level is here. The level is here. Or it is continued. Okay, it may be here also. Here also. But it may enter in your mouth. So take care. And there is blood, no? Somebody else's blood. So there may be, we don't know what is there in this blood. Okay, so take care. It is not coming into your mouth. When it has just crossed, immediately stop it. So by that, you can prevent entry of blood or blood mixed fluid in your mouth. So after that, you have taken extra fluid. Now you have to bring down the level to this mark. How you will do it? Same procedure. You just release it. Okay, or this way, inclined it. Then you just touch it with cotton. It will be coming down. When it came down to this level, immediately you fold it. Okay. So then make it horizontal. So up to mark I have diluted. Now you mix it. So there is one inside the bulb.
Bead.
This will help in mixing. This bead will help in mixing. So you do it for about 2 minutes. 2 minutes. Again you fold it and keep it there. If you have a garter or a rubber band, fold it and then make it, apply this garter. So this will prevent dropping of this fluid outside the tube. Okay. Now take this. So there are two L1, L2. There are two areas. This is one area, this is one area. You can use this part, you can also use this part. So you will be placing a cover slip there, over it, and then you will be placing it there. Okay. Because cover slip. This is the fluid. Cover slip. In our earlier class, we have shown you, if you place the cover slip, you will find there will be a gap. And what is the height of this gap? 0.1. Okay, fine. So now you will be placing the cover slip over it, and the one end will be on this breeze, another will be on this breeze. So gap will be there. So now you place the cover slip in such a manner so that a part of this grid remains not covered. It will remain open. So we will place this diluted blood on one side of this. So when you you placed one drop, this fluid will coming down the gap. It will fill the gap, and excess fluid will be drained. Okay, so now it is charged. Okay, then you place it under the microscope and focus it. See whether grid lines are there or not. Okay. Okay. So what I am doing, placing the cover slip in such a manner, some part of the grid remains open. Okay. So then you place it on the table. Next part. Remove the girder, and there will be some fluid here. You discard this fluid. Why? Why you have to discard this fluid? Because there is no blood. When we mixed, only this part of fluid is mixed with blood, but this fluid did not get the scope. So if I take the fluid from here, so there will not be any blood cell. So that's where you remove 3 drops. So 3 drops means it will be completely, this will be out. Okay? Then blood mix fluid will be coming. So then only you see, you notice one drop is coming, immediately place that drop in the open area. Okay, the tube should be at 45-degree angle. Okay, then so blood drop is at the tip, so touch it, yes. Automatically it will come inside. Okay, then you place it under the microscope and see it. Wait. Under the microscope, 5x, you will find these grid lines under the microscope. So these grid lines are there. In both areas you will find. From here to here, it is 3 millimeters. How much?
3 millimeters.
From this end to this end. This end to this end. Again 3 millimeters. So it is a square. Side is 3 mm. Now we divided this 3 mm into 3 parts. 1 mm, 1 mm, 1 mm. So this is 1 mm, 1 mm, mm. So this is the large block. Okay? So this is one of the small block. This is one of the small block. And I am forgetting these 4 blocks. Okay? Let's see what is there inside. So this is also 1 mm. This area is also 1 mm, side is 1 mm. And this is also 1 mm. 1 mm, 1 mm, 1 mm, 1 mm. For RBC count, this is our point of, this is area of interest, the central one. Okay, now you see, look at this carefully. So here this is 1 mm, 1 mm, sides are 1 mm. Now we have divided it into 1, 2, 3, 4, 5 parts. So what would be the side if you divide it into 5? 1 by 5. Okay, write 1 by 5. Okay? Pen. So, from here to here, side is 1 by 5. Here to here, 1 by 5. So 1 by 5 into 1 by 5, this is the area. And what would be the volume? 1 by 5 into 1 by 5 into 0.1?
Yes.
Into 0.1. So this is the volume of this area. This is also same. This is also same. I will count RBC, number of RBC present. So I will, this area for RBC count. For me, it is not possible for count all how many RBCs are there in all these blocks. Not possible. So it will be possible, but it will take long time. So what I'll do, I'll choose 5. From this area, I'll choose upper right corner, left corner, upper right corner, lower, and the central one. See, here I divided into 4 divisions. There is 4 divisions. 1, 2, 3, 4. Here I am getting 5. Why not 4? I could have done it. Here can you find the central? No. But here I will be getting the central one. Okay. So that side has been taken. Sir, why you have taken 5? Okay. I want to know the average height and weight or BMI of medical students studying in Agartala. Average height and weight. So what I have to do? Is it necessary to study all the 150 students of TSMC, all the students of TMC, all the students of AGMC? No need. I'll take a sample from TSMC. And how I'll be taking the sample? Randomly. Randomly I will be choosing. I will not be opting. Oh, his height is better. She is shorter. No, I will not take her. His height is good. I will take him. I will not be choosy. So, how I will do? So, I have the roll. I don't know your 2 roll numbers. So, it is mixed up. Then what I will do? I will take 1. I don't know which roll number it is. 2, 3. I will take from here only, say, out of 50, I will take only 50. So, out of 150, I have taken 50. So, this is the sample from. This is randomly done. Or else, okay, I will take 50. So, if I take 1, then I take roll number 3, then give a gap, same interval. After giving a suitable interval, I will be choosing this one. This is another procedure. So there are a lot of procedure of random sampling. So in this way, I'll take a sample from here, take a sample, and this sample is the representative of TSMC. It means statistics says, if you choose the sample randomly, and the random choosing sample size should be adequate. There is an equation. For 150 student, how many students you can choose randomly? So that is determined, suppose it is 50. So I'll take 50. And this 50 will represent 150 of this college. Similarly, I will take 50 in the same manner from there. Then how many students I got? 150. So I'll now sum their what is the sum of their weight? This must divide it by 150. Then I'll get the average mean weight. Similarly, I'll get mean height. So I can say now, this is the standard average height weight of medical college students studying in Tripura. Okay. Here also, there are lot of box. Now you see, can you tell me how many boxes are there? Such boxes? Total. You have chosen only this one, and this one center. There are other blocks were left, no?
25.
Total how many? 25. Total have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 is 25. So out of this 25, we have taken only 5. So this is the sample. So this sample will provide certain value. If you count all this, it will also provide the same value it is expected. Some variations will be there, but these will be minor variation. You understood this? Why I have taken 5? So this is. Okay. Now, can you tell me what will be the volume of this area? Obviously, you can. You said, no, I am not considering the smallest one. I am considering this block, this one. Within this, there I can see within this there are again some smallest divisions. These are the smallest divisions. Now, how many smallest divisions are there? 16. So I have taken the measurement 1 by 5, 1 by 5. This is 1 by 5. This is 1 by 5. So this is the area or volume of this area. Okay, now let's see what is the volume of smallest one. So again you divide. This is the point 1 by 5, na? This is 1 by 5. So again you are dividing 1 by 5 by 4. What will be the result? 1 by 5 divided by 4. No, 1 by 5 divided by 4. So what is the result?
0.8.
Others? 1 by 5. 1 by 5 divided by 4.
So it is 1 by 5 into 4. 4 by 5. So it's 0.8.
0.8. Yes. Okay. So 0.8 into 0.8. 0.8 into 0.8 into 0.1. This is the volume of smallest division.
0.64.
This is the volume of smallest division. Okay. Now, in one smallest division, number of RBC I have counted 7. What is the volume?
0.8.
0.
How 1 by 5 divided by 4 became 0? It will be 1 by 2, 0. No? How 1 by 5 divided by 4?
Okay. 1 by 5 will be there in 1 cubic millimeter. 1 cubic millimeter. This is present. 7 is present in 0.0025. Then how many RBC will be there in 1 cubic millimeter? Unitary method you calculate.
1 by 4 1 by 20.
Can you do it? You should.
1 by 2, 8,
Because it can be done by class 8 students also.
1 by 2, 8, 0, 0. 1 by 2, 8, 0,
1 lakh.
1 by 2, 8, 0.
No, you give me the total figure. Whether in thousand or in lakh or in million. Some unitary method. This mass volume contains 7.
So what will
1 will contain this. So this is the simple one. You are having calculator. So you calculate it. So what this a number will come?
50?
Huh? 50?
50,000.
Huh? 50,000. Okay. She calculated it as 50,000. Now we know we have diluted blood 200 times. This is the diluted, not the original blood. This is diluted blood. And we have diluted 200 times. So multiply it by 200. Whatever it is you got, it is the RBC content in diluted blood.
1 CL.
Huh?
1 CL. If it is 50,000.
Then you will get the original amount. That is, this mass of RBC present in 1 cubic millimeter of original blood. So this way you can calculate from one small division. Okay. You will be calculating in 16 one corner. Okay. In 16 smallest division. What is the side? Then what it would be the side? 1 by 5 into 1 by 5 into 0.1. This volume will contain, say, there are how many 16 divisions total. So each division roughly say 5. Then 16 into 5, 80. So suppose there are 100 RBCs. So within this area there are 100 RBCs. Now can you calculate how many RBCs will be there in 1 cubic millimeter? Same? Same? Not same. You are nodding your head, but you have to calculate it now. Calculate. 1 by area is 1 by 5 into 1 by 5 into 0.01. This is the volume. And this will contain, this area will contain 100 RBC. What will be the number of RBC present in 1 cubic millimeter of diluted blood? Use your computer.
Actually, we are taking something wrong. Sir, actually we are taking something wrong because the value is coming 1 by something. Sir, actually we are taking some calculation figures wrong because the value are coming 1 by something, not in lakhs or thousands.
You see, calculate. First, whether your side of smallest. What is the side? 1 by 5. So multiply it. Is it? 5.8 million.
No, 5 million, sir.
5 million, yeah. Result is 5 million. The result is 5 million. He solved this problem. The result is 5 million. Okay? So let us move to the lab. We will demonstrate how blood is taken in the RBC pipette, then how it is diluted, how you have to draw the diluting fluid. It will be demonstrated by him. Come. Blood. So if it is the collected blood, then you have to mix it before using.
In what mark do you draw blood? And if you draw till 0.5, what's the dilution factor?
You will be making from 0.5 to 101. How many times blood is diluted then?
And what will you do if the blood, when you draw, it goes beyond 0.5 mark?
Bottom layer.
You have to use filter paper or tissue paper, not filter paper, actual tissue paper,
Or cotton?
discard the extra blood to make it come into 0.5. And whenever you are seeing the marking or the graduation, you have to keep the RBC pipette in a vertical way, not in a tilted way or a horizontal way. Right?
জুম করে দেখাবে।
Next, you draw diluting fluid, right? That's the diluting fluid. Till what mark do you draw? 101. And if it crosses beyond 101, what do you do?
Same process.
Same process, right? Oh. Block it, then no, block it, yes, sure, দেখো এটা 101 of place.
Mixing করে তারপর
Now you have to see till if it has been 101. So if there is more fluid, right, so you have to make it again till 101. Okay. And whenever you basically discard the extra fluid, you have to make sure that you block this part of the pipette with your thumb and make it like that. Why? Because it's a pipette, right? It has hole in both the endings. So because of that, what will happen is because of this air pressure, the fluid may drop down. So once you put your thumb and also make sure it's folded here, the tube is folded, right? So there is no chance of any extra drop after 101 it is been made, there will not be discarding of any other drop of diluting fluid. Then when it is still 101, you keep it horizontal in between your two pumps with the tip still covered with the thumb, and then you mix it, right? Mix it for how many minutes? 2 minutes. 2 minutes, right? So you mix it. Where does the mixing happens? Where does it happen? What is the name of the part?
Bead.
Bead is not the part. Where in the RBC pipette the mixing happens? Bulb. So you do it for 2 minutes, right?
This area, this is the charging area.
We can do either one.
This is a diluted.
So sir was showing you how does a Newbert's chamber looks like. A Newbert's slide above which you put a cover slip, right? And the cover slip is not in the edge but a bit away from the edge, so that you get an area to charge the diluted blood sample, right? Now it's more than 2 minutes, I guess. Now what we'll do?
Several chairs. Okay,
Now what we'll do? We'll directly charge the chamber, or
keep it there.
remove. How many drops?
3 drops.
3 drops. Why?
সাইডে ড্রপটা দেবে ওইটা নাম করে লাগবে
Yes, in the other than the bulb area, only in the bulb area it got mixed. So till the mark of 1, that is basically no blood. It's only the diluting, right?
তোমার থিওরি কাজে লাগালে হবে না তো
But 1 to 2.
এটা আগেরটা আগে করতে হবে তুমি কইরা তারপর এক্সট্রা ব্লাডটা ফেলার মানে কি জানো নি কারণ আমি যখন এটা করব তখন এই এরিয়া তো ব্লাড চলে আসবে মিক্সিংটা হবে তা আমি তো শুধু ফ্লুইডটা ফেলতে চাইছি
না স্যার অ্যাকচুয়ালি কি হয়েছে আমি কনফিউশন করে নিয়েছি
হ্যাঁ করুন আমরা যেমনি করি এমনি শূন্য তোমার থিওরিটা তোমার এটার পেছনে সায়েন্সটা অন্যরকম আমরা বলার পেছনে একটা সায়েন্স আছে বুঝতে তো এই জন্য ওইখানে কিছু বললাম না ডাক দিয়ে বললাম
It is been charged.
Sir escaped the tube at 45-degree angle. So one drop came at the tip. He just placed the drop at the margin. Now you see, have a look, one by one. Then you will be going to your place.
See, once you put the drop there, right, it will charge throughout the chamber, throughout the grid area, basically. Okay. Then what will happen to the extra amount of fluid? Because it will drain into the gutter, that H-shaped gutter we have told, right? Okay. Now take one tissue paper, because there can be excess amount of fluid over the cover slip or in the edge. To try to just touch it.
See,
The
it is
extra
done.
fluid will just soak into the filter paper or the tissue paper.
While he placed the drop, some amount of the liquid entered under the cover slip and some amount deposited over the cover slip. So the fluid over the cover slip, you have to remove it
Just touch
by
it, right?
you just touch it.
Just touch it.
Touch it, automatically the fluid will be absorbed.
Okay, it will get soaked into the.
Just over the touching over the not by the side, because that again the fluid that is entered, no, that will come out.
and make sure that you don't you should make sure that that cover slip is still in its place. You can just move the cover slip here and there, right? While
Okay.
soaking. So
আর কোনো মাইক্রোস্কোপ আছে খালি
this is called
যেটাতে ও শো করতে পারবে?
this is called charging, right? This is called charging.
Achha.
Charging of the chamber. What chamber?
With what?
With the diluting fluid.
Diluted blood.
Diluted
Okay.
blood.
Now, such charged Newborn chamber was placed. There are three such slides that were placed over under the microscope, and these are focused. So now you see, since it is focused, now you will be able to see the 16 divisions. So you have to count following the same principle as it has been taught in the class. Following the same principle, you will be counting. We have already counted it. And we will match our value with yours. Okay, then you will be knowing that where you have done mistake. Because all the values for all the 16 smallest divisions, okay, we are having. So then you can compare it. So you will also be, while you will be counting, there are 16 divisions. There are 16 divisions like that. So you will be starting with this. So suppose you got it 5, here write it 5. Then in the 9, write it in that way. Then you compare with our values. So this may be identical to our value. This may be varied. Why it is varied? Just check. If you have got any doubt, clarify it. Try to make it clear. So now there will be again 3 cues. 16, 16, 16. There are 3 microscopes.
আমাদের দিয়ে উঠছে নি করে কালকে आपका हो गया वो उधर जाकर
माइक ऐसे
बनाओ मैं दिखा दूंगा तो आप क्या सीखोगे बोलिए আচ্ছা ঠিক আছে শিওর নি এটা ঠিক আছে এটা ঠিক আছে নি
স্যার আমি কাল গিয়েছি
Then physiotherapy আরেকজন
প্র্যাকটিক্যাল তো স্যার থিওরি একসাথে ক্লাসটা শেষ তো
ঠিক আছে ছাড়ো না এখন ঠিক আছে
আর এখানে অ্যাকচুয়ালি হয় না স্যার আমি জিজ্ঞাসা করছি স্যার থিওরি কি নেবেন এখানে কোনো না প্র্যাকটিক্যাল আমি এই বিষয় নিয়ে শুধু প্র্যাকটিক্যালি কেন এটা এটা লাগানো ও আচ্ছা নাও আছে এটা লাগানো ধরুন লেকচারে কোনো টপিক হইছে এটা লাগা প্র্যাকটিক্যালি কেন থাকে তাই প্র্যাকটিক্যালি যদি মিল থাকে এটা লাগানো আমি ভাবছি যে আপনাদের মধ্যে প্র্যাকটিক্যাল যদি এরা রিকমেন্ড করে তুলে দাও
आप इनका मत देखना ये करेक्ट हो रहा है आपको मालूम है
सर दो तो पता है सर
দেখে বলেছি এখন দেখে নাও পরে 7 ক্লিক করে দাও এখন দেখে নাও পরে 7 ক্লিক করে দাও দাঁড়াও না আরাম করো তুমি টোটা পিছনে না করো জানি जी मार्क किधर है ये जी मार्क किधर है
Voice very low. I don't want to get this one.
छोड़नी पड़ेगी
बढ़े दे बोले बढ़े दे बोलो ना
जो मत पूछो आप करो
So within this area, was no point in discussion. So first you
হয়ে গেছে না
फर्स्ट टाइम से ज़्यादा टाइम
हेलो 2 मिनट
सर फर्स्ट टाइम ज़्यादा टाइम
नहीं टाइम चला जाएगा अभी 3:45 बज गए ना
every